So I got this like React page here that's like loaded up with Vite, and I have about 4,093 components. So every time you see like a little blue square, that is a component, and inside that component we have children, and those children have more children. So if I show you the actual like recode, this is just a recursive component that keeps on creating itself, and I put a timer to see like, okay, how long does it actually take to finish rendering everything? Okay, so if I look at the actual application here, I have this other stuff here, which I could probably just get rid of, honestly. I get rid of all this right now, and I have the speed component, right? So the speed component, if I want to kind of make this more accurate, I guess I could delete everything. All the speed component does is it renders out these blue things recursively. And on a clean page refresh, you see it takes about 1 second to render out 4,093. And let me just show you. So like when you have a lot of components on your page, this is the slowdown that you might see, right? So I'm going to say like count and set count equals a use state. And if you don't really understand how React re-render stuff, basically anytime you change state in a parent level component, that component in every child is going to re-render unless you use like a memo or something, right? So in this example, like this example is kind of dumb because I mean, honestly, like this takes in no props. You'd probably use a memo so that it doesn't keep on re-rendering it over and over again. But just for demonstration purposes, like if I had a button that when you click it, it incremented this count by something. So on click, and I'm gonna go ahead and just call like, I don't know, set count +1. Let me zoom in a little bit. It might be a little small. All right, so this is the component. All right, so now we should have like a button here, and I want to show you that if I click on this button, it does take a while. I mean, it takes like another full second to kind of traverse all the functions again. And even though React is not actually updating the DOM because none of this stuff has changed, inside the actual like profiler, like if I did this again, make sure I waited like a full 2 seconds and click this, you'll see that it's taking about 4 or 3.1 millisecond to render. Actually, those are like probably the highest in the recursion. So this is like one of the probably speed of 1, and then later on in the recursion, I'm rendering smaller and smaller components, right? And they take like less than a fraction of a millisecond. So we're talking like microseconds. So if you look at this whole thing, it takes about 1 second to render out. I don't even know how many components I said, like 4,000 something. You can see like this is just a recursive function. So it just kind of like renders out. Speed is going to render out speed and speed, which is going to render out 4 speeds, which renders out 8 speeds, etc., all the way down. And let me show you the code real quick. So this is the component of speed. It basically just renders itself using recursion. It increments the depth by 1, or the depth by 1, and then it has a max depth here. So this is my base case where it breaks out when we've hit that max depth, and I can increase this or decrease this to make it take longer or take less time. But that's how it all works. So I wanted to kind of show that like React is pretty fast at rendering out a lot of components. 4,000 components, if you think about that, like how often do you have 4,000 components on a page? You probably don't, right? You probably have like, I don't know, 10, 20 input boxes if you're on like a sign up page or like a configuration page of a dashboard. Then you have some like, I don't know, some titles. You might have some like paragraph tags. I think if you're using something like main time or style components, that's when your component complexity might start really increasing because it has to dive into all those custom components. And sometimes those components even do a bunch of other stuff. Like they might have like forward refs and all this other stuff. So obviously like the time that it takes to do this is going to increase as you use like these component libraries that do a lot of stuff under the hood. And I want to state that I'm on an M1 Mac Air right now, and I have my performance throttled by 6 times slowdown. So if I actually turn off my throttling, I want to show you how quick this actually is. I mean, it took 175 milliseconds to do that same rendering, right? So I can bump the max depth up to, I don't know, like 14, 15 maybe. Okay, that might have been too high. I'll do 12. Notice this is recursion, kind of like Fibonacci. So like the moment you bump up the max depth by like the max depth, I keep saying depth for some reason, the max depth by 1, your components created like, it becomes like quadratic. So 16,000 components on my Mac M1 Air took about 778 seconds. And that's every time I do something on the top level state. It's going to rerun all these functions over and over and over again, calculate the class, and do this stuff. So I guess the point I'm trying to make is like a lot of people worry about performance and like re-rendering, and they'll throw like use memos and use callbacks everywhere, but that's a lot of components, right? What page has 16,000 components? I don't even know. Like maybe you have a table that has a bunch of entries, but at some point, like once you reach a certain amount of components, you need to rethink your UX because you're showing too many things on the screen that a user can't even see, right? And maybe it depends. Like if you're trying to use React to build out a game that has a bunch of like game objects, then yeah, you might run into a lot of performance issues. But React wasn't meant to build out games. It's meant to build out UIs that just have like inputs that you can submit to a backend and vice versa, like display some text to the users. So hopefully this was kind of an interesting little video to kind of understand like, you know, how fast can React actually just re-render stuff, right? I'm not even doing the reconciliation by like updating the DOM. I'm just re-rendering. I think if I were to basically pin like a math.random here, like we'd probably see a lot of other performance hits. So if I refresh this page, it takes about 24 milliseconds for a max depth of 10 or 7. Let's do 10. Okay, let's do 12 again. So about half a second for 12. And it actually, for some reason, I think it actually got faster. Maybe not. Let me go back. Let me go back down to 12. This video, I didn't really plan anything. I just want to show like some benchmarking. But with a depth of 12, that's 16,000 components. Took half a second with no throttling. So 5, 7, 3. Go ahead and put that here. And then if I were to go ahead and take out that math.random so that it doesn't actually like re-render the DOM every single time, let's see how long it takes. It takes even longer for some reason. I don't even know. It's like the same. So I guess updating the DOM is not the thing that's slow. It's actually just going and traversing these JavaScript functions over and over again. There might be something that I'm missing in my benchmarking, obviously, because I didn't really spend too much time thinking about this. But you would think having this random number also rendered out and displayed like would have slowed this down tremendously, but it really just doesn't slow it down at all. So my point is like you can render a lot of stuff out to the page with React if your computer is pretty fast. And even if you have like throttling going on, CPU throttling, I mean, this is obviously, I'm gonna have to bump this down to like a 10 now because that's gonna be too many components for a 6 times slowdown. But yeah, I would say just stop worrying so much about like using callbacks everywhere, using memos everywhere, because unless you have a ton of components you're trying to render, like React can handle it, right? That's all I wanted to kind of talk about. And hopefully you learned something. Feel free to leave a comment below if you think I just said something completely incorrect, which I probably did and I do at times. So be sure to correct me, call me out in the comments. I love when people call me out because it helps me become a better developer. And yeah, be sure to join my Discord if you want to talk to me directly or ask some other people who are trying to learn how to code. And you know, I'm trying to build like a friendly community of people who are just willing to help others when you're stuck on a problem. Sometimes I'll answer your questions, sometimes I won't. Depends on my time. Anyway, have a good day and happy coding.